Okay, this is MAT 175, Lesson 8, Section 3.5, Inequalities involving quadratic functions. And so here we have an inequality, quadratic equation, x squared plus 5x plus 4 is greater than 0, and we want to graph that. Okay, so basically we're going to graph the function x squared plus 5x, but first we have to find the intercepts. We have the y-intercept, we set x equal to 0. We put 0 in for x. Set x equal to 0, solve for y. In this case, we're solving for f of x. So we put 0 into the x's, and we get y, or f of x, equals to 4. So that would make it 0, x is 0, y is 4 for the y-intercept. And now we want to find the x-intercepts, so we set the y equal to 0 and solve for x. And so when we do that, we have to factor. And so we're looking for factors of 4 that will add to give us 5. And so we're going to use 4 and 1, set those equal to 0, and we get x is a negative 4, 0, and we got x and a negative 1, 0. So we put those on the intercepts. We also have to find the vertex. And so there's where we get there's that negative b over 2a again. Well, the x squared, that's our a, coefficient of x squared, that's our a, 5, that's going to be our b, 4 is our c. Well, we only need a and b. So the b, that's going to go in there for 5, so here's a minus, and then 5 goes in there, over 2 times a, well, a is 1. So that'd be negative 5 halves, or 2 and 1 half. Well, that's only the x coordinate of the vertex. So we have to substitute that back in to the x's to get our y coordinate. And so when we do that, we end up with negative 9 over 4. Okay, now what you can do here is you can put this negative 5 over 2, store it into x, and then put this equation into your calculator, hit enter, and if you get a decimal, then hit math frac, and there's your vertex. Okay, so here we have negative 5 halves and negative 9 over 4. So we have our y-intercept, we have our x-intercepts, we have our vertex. So now we can go ahead, here's our vertex, negative 5 halves, negative 4, or 9 over 4. We have here next negative 4, 0, that's here, and negative 1, 0, that's here, and here's our 0, 4. And so we can draw our parabola, and the parabola is going to be symmetrical about the vertex. So this would be like our axis of symmetry here, right where the vertex is, and so whatever comes on one side is going to come back up the other side the same way. Alright, and now we want to know, where is the function greater than 0? Well, we look at where is the function in relation to the x-axis, and whatever is above the x-axis, that's where the function is greater than 0. In other words, we're looking at the y values that are greater than 0. So the function is greater than 0 over here from negative infinity to negative 4. And since we're looking at greater than, that's going to be open, because we don't want it right at negative 4, we want it greater than negative 4. And so that'll be open at negative 1 to infinity. So we're looking at negative infinity to negative 4, open because we want it greater than 0. We want it greater than where y is 0. And then negative 1 to infinity. Nothing in between, because in between here, this is less than 0. And so that's a different question. Okay, so that's what it would look like on the line graph. Okay, next problem. Solve the inequality and graph the solution set. So with this problem, pause it, try to find the x-intercepts, try to find the y-intercepts, try to find the vertex, and then graph it, and then play the tape and see how you do. Okay, hopefully you paused it and you tried it, and let's see how you did. First thing you have to do is you have to get everything to one side so that it's less than or equal to 0. So we have to apply minus x and to both sides, and we have to apply minus 6 to both sides. So that's what we're doing, rearrange the inequality so that 0 is on the right side. And we get x squared minus x minus 6 is less than or equal to 0. Okay, and now we want to graph it, so we have to find our intercepts. And I always like to find the y-intercept first. Basically, you're putting 0 in for x, and whatever's left is your y-intercept. Well, you could look at whatever has an x, you know that's going to be a 0, and so whatever's left over is a negative 6, but you got to make sure you include that negative in there. So we put 0 in for x, 0 in for x, 0 in for x. What we have left is negative 6, so this would be x is 0, y is a negative 6, so that's our y-intercept. And now we have to find our x-intercept. So we put y in for 0 and solve for x. And we factor that. And we have to look for factors of 6 that will subtract, because our signs are opposite. And that would be minus 3 and plus 2 to give us our minus 1x. Alright, and then we set those factors equal to 0, and we get x equals to 3 and x equals to negative 2. So this would be our x-intercepts at negative 3, 0, and our positive 3, 0, and negative 2, 0. And so we have here x equals 3 and negative 2, so that would be 3, 0, and negative 2, 0 for our x-intercepts. So now we need to find our vertex, and we use that negative b over 2a, and so a is 1, b is a negative 1, so we put in 1 over 2 times negative 1, and the negatives cancel, and we get 1/2. Alright, now how do we find, that's the x coordinate for the vertex. How do we find the y coordinate? Well, you should have said that we're going to take the x coordinate, and we're going to plug it back in to x into our function. And we get negative 25 over 4. Okay, so our vertex is 1/2 negative 25 over 4. Okay, and so here's our x-intercept, negative 2, 0, and positive 3, 0. And here's our y-intercept at 0, negative 6. And here's our vertex at 1/2 negative 25 over 4. And we want to know where is the function less than or equal to. Now the last one, they asked for greater than. This one's asked for less than or equal to. So now we're including these points. So which way are we going to go, above or below the x-axis? Yeah, you should have said we're going to go below the x-axis. So what points are we looking at here? We're going from negative 2 to 3. And are they going to be open or closed? Open parentheses or closed brackets this time. You should have said closed brackets because it's equal to. We're including these points this time. So that's going to be bracket, negative 2 to 3, close the bracket. And so that's what it looks like on our line graph. Okay. So let's take a look at the next problem. Solve the inequality and graph the solution set. Alright, so pause the video and try this one. Alright, what we want to do here is solve the inequality x squared is less than x plus 6 and graph the solution set. Here we have a different method where we have f of x is x squared and g of x is x plus 6, and we're saying f of x is less than or equal to g of x. And so we have f of x is one parabola, g of x is another parabola, is a line. And so here's a parabola for f of x equals to x squared, and then here's g of x, the green line, is x plus 6. And so we're looking at these 2 points of intersection. So basically we set x squared equals to x plus 6, apply minus x and minus 6 to both sides and factor, and again we get 3 and negative 2, and here's negative 2, that's one intersection point, here's 3, that's the other intersection point for the 2 curves, parabola and the line. And so when we plug 3 in, we get 3, 9. And when we plug negative 2 in, we get negative 2, 4. And so that's how you find the points of intersection between these 2 equations. And we want to know where is f of x less than or equal to g of x. So here's f of x, here's g of x, and we want to know where is f of x less than or equal to. Well, this is g of x here before we compared the parabola to the x-axis. But now we're comparing the parabola to g of x. So if this is g of x, do we want to look at f of x above g of x or below g of x? We want to know where is f of x less than. So you should have said we want to look at below the g of x line. So that would be, again, between where x is negative 2 to 3. And so it would be basically the same thing, except for now we're comparing the 2 sides. Alright, here we have solve the inequality and graph the solution set. First we want to graph f of x. And so we, this time we're going to find the vertex, negative b over 2a. So the a is negative 2, and that goes down here. And then 8, that's b. And so the negatives cancel, and so now we have 4 divided by 8 is 2. So our vertex is at 2. Our x-coordinate for our vertex is 2. Well, how do we find the y-coordinate? Okay, you should have said we substitute that back in for x and find the y. And so we did that, and so our vertex is at 2, negative 1. Okay, and so now we're going to find the intercepts. Plug 0 in for x, and our y-intercept is at 0. X is 0, y is a negative 9. Now how do we find the x-intercepts? You should have said put 0 in for y, and then solve for x. And so what happens when you do that is you're going to find that you have a parabola that opens below. It opens down and opens below the x-axis. So there is actually no x-intercepts here. If you were to factor this, you'd see you'd have to use the quadratic formula, and you're going to get an imaginary in your quadratic. Your radical. You're going to get a negative inside your radical for your quadratic equation. And so that means that there's no x-intercept. So with that, we have no x-intercept, but we do have a y-intercept. So here we just operate off of your y-intercept and the vertex, and then we just draw it from there. By symmetry, we have a point at 0, -9. So here's 2 units from the axis of symmetry, and so the other point's going to be 2 units, so that'll be 4, -9. And that's where that comes in. So, and here the function is always less than 0, so the solution is all real numbers, or -infinity to a positive infinity. Okay, and that concludes this video.